You might have heard of the National Aeronautics Space Administration before, or NASA for short. They've done quite a few awesome things like putting the first humans on the moon, landing robot cars on Mars to explore it and take pictures of rocks that look like faces, and other crazy stuff like sending a space probe called Voyager 1 on a mission that got us the closest we've ever been to Pluto and past our solar system to uncharted space. These might be the things you associate with NASA, and rightly so. But NASA has done a lot more than just space travel. In order to get out of the atmosphere, into our solar system and beyond, they have had to invent many new technologies. The ingenuity of NASA has got us to space, but the technology required to get there benefits our lives all the time without us even knowing it came directly from space. Here are a few really cool inventions that came straight from a rocket ship. Discoveries while observing astronauts in space have led to improving seat design in cars, making them much more comfortable. Also, they invented something called Tempur foam in the 1970s. This improved seat cushioning and crash protection. The name sounds familiar from Tempur-Pedic beds. You've probably heard of them. They're the super comfortable memory foam beds that save you from stains when you're bowling in your bedroom. NASA helped produce a material used to protect the antenna of infrared heat-seeking missile trackers. This material, called polycrystalline alumina, proved to be a good substitute to old shiny metallic braces as they were more aesthetically pleasing. These braces became instantly popular and are one of the most successful orthodontic products to date. In 1994, NASA developed life shears out of technology used to decouple different stages of rocket boosters. Life shears are used in emergency and rescue situations to help victims trapped in wrecked cars and collapsed buildings. These are more effective than previously used hydraulic cutters. Also, they're quieter and more reliable. The life shears have saved thousands of lives, including freeing trapped civilians from the 1995 Oklahoma City bombing and the 9/11 attacks on the World Trade Centers. One of the main necessities of life is water, so astronauts have to take up water with them. But every single pound matters when you're going into space. So NASA had to find a way to supply clean water to astronauts and maximize the use of the limited supply they could take with them. To combat this problem, NASA worked with Umpqua Research Company to create filter cartridges using iodine to clean water supplies on the shuttle. This technology is called microbial check valve and has helped to supply clean water for human consumption in areas where clean water is not easily found. NASA is still working on this and improving its technology to create filters that can even recycle some human waste into safe, drinkable water. This technology was used in production of this thing called the OKO water bottle. It can instantly purify water from contaminants such as disease-causing microbes like Cryptosporidium and E. coli. There are a ton more inventions, for instance 3D endoscopes to boost safety in surgery, a vision trainer to help train your eyes in focusing, wing design that cuts billions in fuel costs, shock absorbers to save structures and lives in earthquakes, laser imaging video camera, magnetic fluids to deliver better speaker sound quality, and many more. NASA is continually developing new ways to keep their astronauts safe and in good conditions in space, and that is helping to produce innovations that will lead to a better future. So keep exploring, it might just lead to a better world.
game on the International Outpost. 30 seconds into the flight. Atlantis almost 2 miles in altitude, almost 6 miles downrange from the Kennedy Space Center already, traveling 500 miles an hour. The 3 liquid fuel main engines now throttling back to 72% of rated performance, going into the bucket, reducing the stress on the shuttle as it breaks through the sound barrier. 55 seconds into the flight, all systems operating normally, 900 miles an hour. The speed of Atlantis right now, 6 miles in altitude, 9 miles downrange.
Atlantis, go with throttle up.
Copy, go with throttle up.
The throttle up call acknowledged by Commander Charlie Hobaugh, joined on the flight deck by pilot Butch Wilmore, flight engineer Randy Bresnik, and Leland Melvin. Seated down on the middeck are Mike Foreman and Bobby Satcher, kicking off their work week with a Monday commute to orbit. 1 minute, 30 seconds into the flight. Atlantis 13 miles in altitude, 15 miles downrange, traveling almost 2,000 miles an hour. Three good auxiliary power units, 3 good fuel cells, 3 good main engines. One minute, 50 seconds into the flight. 10 seconds away from solid rocket booster separation. Booster officer confirms staging a good solid rocket booster separation. Guidance now converging. Atlantis steering into the center lane of Highway 129 en route to the International Space Station. 2 minutes, 20 seconds into the flight, 34 miles in altitude, 48 miles downrange. Atlantis traveling 3,200 miles an hour. The propulsion officer in mission control reports that the orbital maneuvering system engines have ignited. Atlantis kicking on the afterburners.
Copy, 2 engine down.
Atlantis flying on the singular power of its 3 liquid fuel main engines, draining about a half a ton of fuel per second from the large fuel tank. Coming up on the 3-minute mark into the flight, Atlantis 46 miles in altitude, 81 miles downrange, traveling almost 4,000 miles an hour. Atlantis speeding straight as an arrow toward its date with the International Space Station Wednesday morning. Three and a half minutes into the flight, all of Atlantis' systems functioning by the book. 55 miles in altitude, 120 miles downrange, traveling almost 5,000 miles an hour.
Atlantis, negative return.
Atlantis copies, negative return.
Atlantis now too far downrange, too high in altitude to return to the launch site in the event of an engine failure. All 3 engines performing perfectly. 4 minutes, 20 seconds into the flight. Atlantis now 62 miles in altitude, 180 miles downrange, traveling almost 6,000 miles an hour. All systems performing normally. Atlantis on course, on track for its preliminary orbit. The Environmental Systems Officer reports a good flash evaporator system activated for Atlantis, providing cooling for the shuttle's avionics until the payload bay doors are opened about an hour and a half into the flight.
Atlantis, press to ATO.
Copy, press to ATO.
That call up from Capcom Chris Ferguson indicating that Atlantis can now make minimal orbital altitude targets in the event of an engine failure. However, all three engines continue to perform normally, as do the auxiliary power units and the three power-producing fuel cells. 5.5 minutes into the flight, Atlantis now 67 miles in altitude, 312 miles downrange, traveling almost 8,000 miles an hour.
Vicksburg, single engine ops 3.
Atlantis now beginning to roll to a heads-up position, the main engine swiveling, enabling the shuttle to move to a heads-up position above its fuel tank, gaining more favorable communications through the tracking and data relay satellite system as it heads uphill.
Atlantis, Presta Mico, single engine Zaragoza 104.
Presta Mico, single engine Zaragoza 104.
That call from Capcom Chris Ferguson to Commander Charlie Hobaugh indicating that Atlantis can make normal orbital cutoff targets in the event of an engine failure.
Go for the pitch.
Okay, nominal shutdown, go for plus X, go for the pitch.
Now 6 minutes 45 seconds into the flight. Atlantis 66 miles in altitude, almost 500 miles downrange from the Kennedy Space Center, traveling almost 11,000 miles an hour. 90 seconds left in powered flight.
Atlantis, single engine press 104.
Single engine press 104.
Coming up on the 7.5 minute mark into the flight, the main engines will once again be throttled down to limit the stress on the shuttle and its 6 crew members to that of 3 times the effect of gravity. Atlantis approaching a speed of more than 4 miles a second. At the time of main engine cutoff, a minute from now, Atlantis will enter its preliminary orbit at a speed of 5 miles a second. Seven minutes, 40 seconds into the flight. Atlantis providing 8 minutes, 10 seconds into the flight. Standing by for main engine cutoff. Main engine cutoff confirmed by the booster officer, standing by for external tank separation. And the bird's eye view from the external tank camera of external tank separation. Atlantis now in its preliminary orbit. Commander Charlie Hobaugh will now maneuver Atlantis so that cameras embedded in the shuttle's umbilical well can perform photography of the discarded external fuel tank. And Mike Foreman and Leland Melvin are about to use digital still and video cameras to capture handheld imagery of the tank for downlink a few hours from now. A flawless climb to orbit for the shuttle Atlantis and its 6 crew members en route now to the International Space Station.
Mico ohms 1 is not required. Fergie will meet you in the post ohms 1.
And we'll see you there, Scorch.
Hey, Fergie, for com.
Go ahead.